In this video, we're going to talk about expanded octets. So the one thing that's helpful to remember is that in the periodic table, the second period, lithium, beryllium, all the way over to neon, those are in the second energy level, so n equals 2 at that level. And there are a total of 8 spots for electrons to go in. And so that is where this idea of the octet rule comes in. So everything in the second period definitely follows a rule that favors the formation of octets. For everything in the third period, however, where n equals 3, we've got 3d orbitals, and there's nothing in them, which means that there is space to expand the octet. Now, if we can form a compound that has 8 electrons around it, that's great. However, we also have the ability to expand the octet because of these 3d orbitals. So because those are there, we have the ability to add more than 8 electrons. So we can go over 8. Okay, and if we want to see what that looks like, we can look at what is the Lewis structure, or the best Lewis structure for the sulfate anion, and that is SO4 2-. And if I was to draw something that obeys the octet rule, it would look like this. Sulfur brings 5 valence electrons, oxygen brings 4 times 6, which is, sulfur brings 6 valence electrons. So I have 5 groups of 6 plus 2. So I've got a total of 32 valence electrons that should be in this structure. And this is a structure with 32 valence electrons. I've got 4 groups of 8. And the formal charge for, let's say, this oxygen would be -1. Same here, here, and here. And the formal charge for the sulfur would be +2. Let's see how that happens. Sulfur has 6 valence electrons, -4 bonding electrons, -0 non-bonding is +2. So while this is a Lewis structure that obeys the octet rule, I've got 4 -1s and 1 +2. And that is not great. So if I was to do this again, I could draw it like this instead. Everybody, oops, not those. All the oxygens still have octets because they're in the second energy level, but the sulfur here has 1, 2, 3, 4, 5, 6 bonds around it. It's got a total of 12 electrons around it, but that is okay. If I do the formal charges here, this has a -1 charge, this has a -1 charge. The sulfur, 6 minus 6 minus 0 gives us 0. So this is still a good Lewis structure for this. Actually, it's a better Lewis structure. And then the double bonds don't have to be there. They can be in other places, and that's resonance. Xenon tetroxide is going to work in kind of the same way. So xenon tetroxide is this. This brings 8 valence electrons, 4 times 6, so again 32. And if I draw one that obeys the octet rule, it looks like this. But you can see here that each oxygen is going to have a -1 formal charge. And xenon here is going to have a +4 formal charge. That's a very high formal charge. And again, the way we get that is 8 valence electrons for sulfur, -4 bonds, and no non-bonds is 4. It's huge. Can't have that. So the best thing we can do is put in double bonds. It may look like xenon is overloaded with double bonds here, but it's got an n that is higher than 3, so it's able to go into all these different areas. So this is the best Lewis structure we can draw for this one. Now, there are other ones that have incomplete octets. There's only a couple examples of these that you really want to pay attention to. Aluminum chloride would be one of them, so AlCl3. If I was to draw the Lewis structure for this, it looks like this. And everything here has a 0 formal charge. I'll do aluminum for example. Aluminum has 3 valence electrons, -3 bonding electrons, and no non-pairs, 0. But you're probably thinking to yourself, that doesn't have an octet. So it should probably look like this. And when it does, Again, aluminum has 3 valence electrons, minus 4 bonds, and 0 non-bonds is -1. Chlorine has 7 valence electrons, minus 2 bonding electrons, minus, there shouldn't be 3, there should be 4. It's +1. Excuse me. So this has a +1 formal charge. And the issue here is that things like halogens tend not to get +1 formal charges. These are electronegative, and they'd rather have a negative formal charge if they're going to have anything. So this is not a very good Lewis structure. Okay? And a quick, easy thing to remember is that if I've got things like nitrogen, oxygen, or fluorine, these are happiest. Nitrogen's happiest when it has 3 bonds and 1 lone pair. Oxygen has 2 bonds and 2 lone pair, and fluorine has 1 bond and 3 lone pair, and that is sort of true for everything underneath it on the periodic table. That is how you obtain a 0 formal charge. Okay, so good luck with that as you try to explore incomplete and expanded octets.